Hi, today what we are going to do is whatever we finished on the first 2 days, like the USA layer model and the TCP/IP layer model. So what I want to show you today is that how do we link these things with the graphics? How does they look like? So if you're looking at the packet tracer, so this is a tool, this is software, which for CCNA we are using to do our labs. So what it contains different Cisco devices. So for example, if you look on the screen, they are on your just on the left corner right there. So these are Cisco routers, Cisco switches, computers and network cards and the cables and all kind of things. So the first thing is when I click on this and I want to pick up a switch. So when you click on the switch here, you can see on your right hand side there are different type of switches. So these different type of switches means, for example, 2960 or 3560 or 3650. Remember in the layers, I told you that on a data link layer is all physical, and a data link layer we figure out that whether we are using a Ethernet topology or we are using a fiber optic or we are using a wireless. Because in CCNA, there are 80 to 90% things are done on Ethernet. So that means we are going to go and pick up the Ethernet. So for example, layer 2. So what I'm doing is I'm picking up 2960, which is a layer 2 switch. Now can I do the layer 3 switch also, which is dealing with two things. So this is layer 2 plus layer 3. So this means it is doing the hardware plus the logic, the routing things. But first I want to make sure we are looking at normally what they are concerned in this course is about layer 2. So what I'm going to do is I'm going to go and switch it off. Let's clean it off, the other one. So you can go on your right code right there on the top, X, and then you click here, say, well, I don't want this, and then cancel it out. And you will see that you're left with this. This is number one. Number two, now I want to put a computer. So I want to go and add a computer. Like a normal at home, you have 2-3 computers. So what we do is we always have 2 or 3 computers, or more than that on a LAN. So what we do is we go and add all these 3 computers into a switch. Now, the first thing is we are going to go and after putting this topology, we need a cable. So you can see that this yellow thing, the Thunderbolt, so what we're doing is all type of cabling. Now the first thing you have to make sure you understand this one, that when we are connecting computers and switches, the computer and the cable which we are going to use, we call it a straight through cable. It's a thick black cable. Right there at the bottom, its system shows you copper straight through. So copper straight through cable means what we call is, if you want to connect different layer devices, that means I am connecting layer 2, which is switch, and the computer, which is logical like network or application layer. So I need a cable, which we call a straight through cable. Now straight through cable basically means, because the Ethernet cable has 8 pins, 1 to 8. And then when the computer is transmitting in a straight through cable, computer and router, they are the logical things. They always transmit on pin number 1 and pin number 2. Make sure you understand. Pin number 1 and pin number 2. So they transmit. Switch is a layer 2 device. So switch 2 is receiving that on the same pins 1 and 2. So this is called straight through. So this computer is sending on pin 1 and 2 transmitting, and the switch is receiving on the port 1 and 2 pins. So let's connect it. So you can see that this is the computer, fast Ethernet, that means 100 megabits per second. And then I want to connect with the switch. So you can see that in the switch, there are so many ports. So mostly 2960 has all fast Ethernet ports. So fast Ethernet 0/1. So 0 means slot number. So you can see throughout it is 0 slot. That means there's only one slot. And the port number always starts from 1 to, it keeps going up to 24. And then the remaining 2 are gigabits per second. So 1 and 2. So that means you are working on 2960 catalyst switch. It has 2400 megabits per second ports and 2 gigabits per second port. Remember, the bandwidth is always, when we say about the bandwidth, it is transmitted in a bits per second, kilobits per second, megabits per second, gigabits per second. So right now we are seeing that I want to connect this one, for example, here is my computer. I want to connect with the fast Ethernet 0/1. So 0/1 again, that means slot 0, port number 1. So you can see that. Now, when you look at that on my computer side, it seems green right away, but not on switch type, because we will learn that later on. That switch takes time to learn the MAC addresses, physical addresses. So that means it takes time to learn what's going around. That's why it is orange or amber or whatever you call it. Similarly, I want to connect the same thing with computer 2. So I pick up again straight through cable, because again, these are different devices with a switch, and this time I want to go pick up port number 2. And then if I go the third one also. So let's go and connect this one with fast Ethernet this, and I'm connecting with port number 3. Now when we are connecting these things, this is called point-to-point. So that means this whole area, this computer is using complete one port. Similarly, the second computer, another port. The third computer, another, the same, so different ports, but it is called one-to-one. They can be one-to-many, many-to-one. That is hub. We will see later on. Now you can see that this machine has learned the address of this. This machine has learned the address of this. And now they are all green. So everything is good. Next thing is what we want to do is, we want to see whether these computers which are connected with the same network, can they see each other or not. But before we do that, I want to click on the switch. Double click here. You can see that it shows you 2400 megabits per second ports. And 2 on the right hand side, these are gigabits per second port. Now if I want to go and configure it, because in exam you make sure you have to go and do the command line. So CLI means command line interface. So when we boot a computer, like a computer, the Cisco has their own operating system which they call iOS. And when you go down all the way, and then you go and click it, okay. So this prompt which you are seeing, this prompt switch with this angle bracket is known as user exec mode. That means user is having an interface with the switch. So basically you can't do many things. So you have to move to the next level. And from user exec mode to go to the what we call a privileged mode. So privilege means you can do something. So what we do is we always type a command called enable. So I will type enable. And now you can see that system has moved into hash mode. This is called a use privilege mode. Now, unless you are in privilege mode, you won't be able to do nothing. Now, you might be saying that anybody can go to privilege mode. The answer is no. We can put a password. But right now, because it is the first thing, let's say this is the switch, you bought it, you open from the box, and then you're working it. So switch name is always switch. So you go to switch. This is now your privilege mode. So once you are in privilege mode, now you can configure. Now to configure it, there are different ways. You want to configure from the console, from the terminal, or from outside, or whatever. So traditionally, because I'm sitting in front of my computer, in front of my switch, so I will say configure from terminal. CUNFIGURE. Configure from the terminal. And enter. So when you say configure from the terminal, you can see that system shows you that, oh, well, you want to configure from the terminal, one per line, and if you want to come back, you can say Control Z. So if I want to go back to the previous state, like switch privilege mode, then I can say Control Z, or I can type exit, or I can type N. Okay, so this is where you go. So for example, I want to call my switch. I want to give a name to my switch, like computer. Remember that you want to call your computer something. So what I want to is, if I want to rename my computer, I want to rename my switch. So the command is host. You can type host name, but host is enough. For example, I want to call my switch host S1. So you can see right away system has picked up host 1. S1 is the name of the switch. Now, do I need to give an IP address? The answer is no, to start with. We don't need to give the IP or nothing. If you don't want to manage it from outside, you don't need to give the address to a switch. Leave it like that. So let's go to the computer. So this is my computer, Ethernet. You double click on that. Now there are different ways of configuring. For example, if you want to, traditionally, easy way is go to desktop. And on your left corner, on the right hand side left corner, you can see IP configuration. Click on that. You can give address from, if you have DHCP, DHCP will give the address. If you want to give a static, so give a static. So let's static, because we are just introducing this topic. So let's make a simplest address, which is 1.1.1.1. System will pick up the subnet mask and then say OK. Go to the second computer, go to the desktop, go to the IP configuration, and then 1.1.1.2, and then system will pick up the subnet mask. Don't worry, when we talk about the IPs, we will be looking into all these things. But today I just want to show you how it looks like. And then we go to the third computer, and then again we go to desktop. We go to the IP configuration, static address, and make sure these numbers which you are putting, they should be unique. 255.0.0.0. So these three computers have IP address now. Now before I move on, I want to show you that whether switch knows the computers, layer 2 switch knows what is in the surroundings. So if you are on the switch, we always run a command show. Show means display. But show command is always at a privilege mode, not at a config or a global mode. This is where we are, because this is your global mode, configuration mode. So if you run a command show, it will not run. So what you do is, you have to go back to privilege mode and run the command. So to go to privilege mode, you simply say exit. So you can see that it takes you back. And now you run the command show MAC dash. MAC means media access control. Remember, layer 2 has all physical addresses. So show MAC address, just put ADD and then press the tab. Sys will complete the command. So at a privilege mode, if I want to display something, what is in my switch, I will say show MAC address table. I want to see the table which contains the physical addresses of on different ports, whatever is being connected there. So you can see there clearly, system has picked up, the switch has picked up the 3 MAC addresses. So port number 1 is computer 1. I don't know whether it's computer 1 or not, but I know I put a computer there. And on port number 2, there's another computer, and port number 3, there's another computer. Now, why this is very significant here is, because if there is no entry here, if there is no entry in the table, when this computer is going to send a message, the switch is going to broadcast onto all other ports, because it doesn't know where to send it. But if you have entry there, like we have the entry there, so system knows that, oh, this guy wants to go to computer 3 or this, because it knows the IP address of that interface. You can see that it knows that what is the physical address of some device which is on port number 3. So it will clearly, if you are on port number 1, you send a message, it will directly give it to that port. Otherwise, if you don't have nothing here, system is going to go and broadcast to all remaining ports. So just imagine you are working in a IBM or wherever you work, and you go early in the morning, 1,000 people are trying to access networks. This is always clear. The switches, MAC addresses, they learn it. So that means when people log on, it takes time, because until they learn all the MAC addresses, then things become very smooth and very fast. So always during your lunchtime or the morning time, log in and everything is a little slow. Okay. So now let's go to this was the hardware part which I showed you, the layer 2. Now what I want to do is I want to see whether I can talk to the computer or not. So if you go to your computer 1 and then you go to command prompt, like Microsoft, if you have Windows computer, you go to Microsoft and say, okay, I want to go and see whether I can access computer number 2 or not. And I know that the computer 2 address is 112. So I will say ping. And remember, ping is a layer 3 command because this is a part of ICMP. I told you from the ISO layer model that at a layer 3, network layer, main protocol is IP, and IP is using ICMP and ARP. Internet Control Message Protocol, and ARP is Address Resolution Protocol. That means broadcast. So it is going to send a broadcast, oh, whose IP, this is the IP, I want to talk to you guys. And then the computer whose address switch is going to figure out, because it's going to send a broadcast, and that machine's MAC address is going to match with that. That machine is going to give this machine its MAC address. Then only they are going to talk. So let's say ping 1.1.1.2. Oh, what was missing? Oh, sorry, I missed that dot because this is 4 octets. Okay, so clearly now this means we were able to ping that computer. Now see, let's look at the layer thing concept now. So what I'm going to show you here is, I'm going to go to the simulation mode. In the simulation mode here is, now what I want to do is, right now there's nothing there, so what I want to do is, I want to go onto this computer again, and I want to run the same command. Ping 11.2 and enter. Look at the simulation mode now. What is sending is sending ICMP, Internet Control Message Protocol. If you go down here, this arrow, say next, you can see the packet is moving. It has gone to switch, and system shows you it has gone to the switch. Then it has gone to PC1, which is 1.1, and now it is going to go broad, because you can see this one. So you can see now when I go to switch, right there here, at switch level when I read here. So the layer 2 Ethernet header, so that means when these computers are talking to each other, because it's a hardware thing, so layer 2 means system is adding its own header. You can see Ethernet header, and it's all media. That means system is using the source MAC address and the destination MAC address. So from computer 1 to computer 2, the source address of computer 0 and the destination computer, this one. Let's check it. So if you are on, for example, on PC1, and now you can see now, if I am on PC1, what is my, and remember I said the encapsulation is called PDU, Protocol Data Units. So outbound, if you are on PC1, and you are saying, okay, what I want to do is inbound Pdu Detail, and I want you to look into this carefully, because as a data link layer, the encapsulation or the PDU we call is a frame. And what the frame contains, frame is the first, look into this. This is preamble, that is 7 bytes, and plus 1 SFD, which makes 8 bytes. So that means start of delimiter. So what system does it when the machine is sending information to the other computer, it generates the preamble. That means alternate ones and zeros, 0, 1, 0, 1, 0, 1, something like that. And then the last one, because it's always 1 0 1 0 1 0 1 0 7 times, and then in the end it always puts 1. That means it is the end of the preamble. Preamble means I'm starting to talk to you. And after that, once it knows that, oh, because the other machine must know that when the other guy started sending me the information. So this is a kind of handshake. Now this machine say, well, I want to talk to, this is the destination address, physical address. You can see that this is BA8 or something like that. So if we go to computer 2, and I will show you if this is where I am. This is computer 2, and this is the interface. Its address is this COCE. Okay, and let's check the source. Let me go up. Okay, so this is the machine which is sending the packet. Then what we are looking at is we are looking at the, oh come on, because now a lot of communication has gone through. So you can see that C0CE, this is the source, this is the destination where this computer has to go. And look into this part. Again, because these are the frames which are always link to link. So this is, in every frame you will have the same thing, this one. But this is the destination computer. This is the source address. So this frame is always first typing the destination address, and then in the frame is the source address. Then is the type. This type is 2 bytes. Basically that means whether you are going to talk to Ethernet or whatever on the other side. And then this is the payload data. How much information you want to send it. Traditionally in Ethernet, well, it is up to 1500 bytes, okay, 40 to 1500. And then the frame contains a trailer, which is a FCS. This is a frame cyclic check because they want to make sure that there is no error at the next link. System is going to check it, everything is okay in this one. So this is the frame which contains your payload, your data, and then it goes to the next one. The bottom part here is, you can see this one, source address is 1112 and the destination address is 111 when you're getting the message back. Okay, and this is all going all around. So let's go and check something. You can see that this is STP. STP is the concept in switches, which we call the spanning tree protocol. We will see what they do. Because the problem with the switches are always, they may go in a loop. Okay. So if you have any trouble with defining the layer, now it makes sense here is. So if you have a computer, you have a switch, so 3 layers are involved. Physical layer, because it is bits and bytes. Data link layer, because Ethernet frame, system has to create frames. And layer 3, IP address, because you want a connection. And ICMP, ARP, and all that is a part of this one. So what we are seeing here is, let me go back to the real one. This is this now. So if you are a part of a switch, let's make a statement here now. If you have a network and you have a switch and you are connecting, you can see we have 24 ports. So clearly we can go up to 24 ports. But let's say we have only one switch. That is what we call SOHO, small home and small office, home office. So you don't have to buy another one, because why to spend a lot of money? One switch is enough. So we can go up to 24 ports because this switch has 24 ports. Okay, you can see. And 2 gigabits per second port. Question is, if I have more than 24, then what I do? Okay, there is a solution. They say, what you do is, you go and, let's see, where is my hub? So you buy a hub. Okay, you buy a hub. Now hub is a physical layer, layer 1. And what you do is you go, let's go and put 1 or 2 computers there. I'm not connecting these straight with my switch, what I'm doing is I'm trying to put these computers, because I don't have extra ports, for example, and these guys are only using Microsoft Office. They are not dealing with the high level graphics, so I can add all of them into one port on the switch. So you go to the cable. Again, hub, switch are same layer because they are physical. Remember, physical. Computers, routers, logic. So because these are different devices, so I need a straight through cable. So you go Ethernet 0, go to the hub. You have seen 6 ports there. So connect there. Go again, another machine, and then another port. Then go to the third computer here, and then you go to the port number 3. Still you have 3 ports left. And now what you do is, from your hub, you use a port and go to your switch and connect with 4. So this means now, this is not one-to-one now, because all these 3 computers are connected with the hub, and hub is simply amplifier. Okay? So question means how it affects our networks. The faction is, if you have more computers in a hub, we call it a collision domain. This is known as, we use a term here in networking, which is called collision domain. Not N. Collision domain means, because traditionally when they are sharing, so when more than one computer may start to broadcast at the same time, so those frames will collide. Like in a highway or on a one-lane bridge, only one guy can pass, and if you are trying to do 2 cars or 3 cars, they are going to collide. So hub means if you are connecting 1 computer, 2 computers, 3 computers, sure, it has to be more than one. They are all sharing the same bandwidth, and they are sending or receiving not at the same time. So either they are sending it or they are receiving it. The question is, how do I know that when I want to send the information, somebody else is also doing the same thing? So this algorithm, we call it. So the collision is going to happen. And this concept is called, in networking, okay, come on, CSMA. And I want to make sure you understand this part. So CSMA CD means collision service message. Okay, so they are going to go and collide. So when they are going to collide, this CD is called collision domain. Can I make it 0? The answer is no, sorry. As long as you are sharing, you cannot remove this part. The moment you remove this CSMA CD or CSMA CD, that means I don't want to share. So when you don't want to share, that means computer is down. So then, if you have more computers, they are all connected with the same hub, 2, 3, 4, 10, whatever number of ports of this hub. They are colliding in this area, this. So if you look at this that means in this port, this is your one collision area. So collision means the frames are going to be discarded, no gain, you are wasting, no bandwidth, very, very slow. Okay, that's why they brought this concept, the switch. Switch has 24 ports, so each port is equivalent to one collision domain. So that means you have 24 areas of collisions. Whereas in a hub, you have only one area of colliding. So clearly, if you have only one area, if you have 100 or 200 devices, they are all sharing the same and they are going to collide. Like on 401 in the morning or in the evening, you can see that, a lot of rush. So this is the basic difference is CSMA CD means must be enabled. This is called half duplex. Either they transmit or they receive, not both at the same time. Never ever disable CSMA CD on a hub. Otherwise, system is not going to work. But if you can afford, you have a switch, you want to give a point to point, so they can send and receive at the same time. So this means sending and receiving at the same time. So basically, according to the Cisco arithmetic, they say, well, you are getting 200%. That means 100% sending, 100% receiving. So a lot of output. But if this is what I'm showing you is, in case there is a problem of your bandwidth, or the ports are not there, and you don't want to buy a new switch, because so that means small office, home office, you don't need to have more than one switch. So you do these things. Okay, no question is, but this is CSMA CD. Collision sense multiple collisions, okay? So system is sensing those multiple collisions. So collision sense multiple access, collision domain or detection. So this CD is collision detection. There is no CSMA CA avoidance. That is wireless, okay? Or if you figure out that, oh, I want to have 0% collision, I'm sorry. The moment you have a hub, you can avoid it. Then you buy a switch and designate or dedicate complete port to your computer. So real life, what we do, main computers are your domain controller, your exchange server, your web servers, your print servers, or your main other servers which are running database. So you give them port to port, point to point. And the others, you go and give them connect with the hub and let them connect with those ports. So now if we go to the switch and let's see how many addresses it has learned. So let me go to the switch. This is where I am. Okay, and then if you enter, enable, remember, it's timing out. So we will figure out later on. It shouldn't be timing out if you are running, if you are getting training. So show MAC address table. You can see that the address is gone because the MAC is in the RAM, like RAM. We call CAM there in switch, but it is like a random access memory. There's a content access memory. So the information which system is going to store it is dynamically picking up. And then if those computers are not talking to each other, there is no communication for a certain time period, system is going to flush it out. You can't keep them forever here. Traditionally, switches, maybe they are having 10, 24 entries. You may put them static, which will never expire. But if you leave it dynamic, that's much better. This is how it goes. So let's see, let me ping a computer again. And what I want to do is I want to give a computer address here, some random computer. And what I'm doing is I'm giving, make sure they should be on the same network. So let's say I want to call it 10.1.1.10. Oh, sorry, 110. We have given 1. And system will pick up subnet mask. Let me go and ping, well, I know this address. Let me ping from here 10.1.1.1. So it is going through the switch. Switch should have some addresses now. Let's go check the switch. And let me run the command again on the switch. Show MAC address table. Oh, come on, where's my mouse? show MAC address table. You can see now 1 and 4. So another very important role here is, because I ping from the F004 port to computer which is on 0 port, F01, system always learns, so when it's sending, it always learns the addresses through the source address, not the destination, source address. So once it knows, oh, this guy is sending out, he says, this is my MAC address and I want to talk to somebody whose address is, I don't know. So you can see now if I go and ping from, let's say from 112 to 10, I will go back here and this is 112. I just want to make sure I know the address and I will ping it. Okay. One dot one dot one dot two, and now we go back to our switch. This is on this port number 2. Let's go and see the MAC address. It is taking its time. In the meanwhile, we can ping one more. So let's see, from here I will ping, what is this address? 113. So, oh, come on. One minute. So we go back to our switch, show MAC address table. You can see now. So 1, 2, 3, 4. So that means my switch knows that who's on port number 0, port number 2, port number 3, port number 4. Okay, this is from the switch point. So it knows the 4 guys are on these ports. So now whenever somebody is trying to access each other, it will be very, very fast because it's all hardware. Now, because I ping one from one of these computers, so we run a command. Remember I said on a layer 3, ARP is also a part of ARP. So this was ICMP which I showed you. And now I want to show you ARP. ARP space -A. Address resolution protocol space -A means all. I want to see to whom I have broadcasted and what is in my cache. So this computer has talked to 111 and 113. So basically, now it makes sense now. So when I ping a computer, I know the address of that computer and say, please, can I get your MAC address, physical address? And because that machine is on my network, it was listening through my switch, because I have a switch, and it sends me its MAC address. And now I can communicate with that. Now these MAC addresses, which I showed you on simulation area, this is where I am. So when I go, for example, when I ping it here, when I do the ICMP, okay, so you can see this one. Layer 3. IP header 112 is asking, well, ICMP messages, or because maybe I'm putting the same computer address. So let's check it some other. This is, let me check what is the IP of this computer. IP config. Oh, we never gave, 113. So let me go ping 1.1.1.4. And now let's check on that one. You can see even there is ARP there, address resolution protocol. ICMP means Internet Control Message Protocol. You are sending a request, echo. You are sending echo and you want to get it back. Look at this part here. 113 is the source address. Destination, I want to go to 114 because my switch doesn't know about the 4 because I never talked to that. So that's why switch is sending a general broadcast, all Fs. FFF, 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 look at it. 4 times this, 312. F, this is hexadecimal. Broadcast. So this is ARP, means a broadcast, address resolution protocol. System say, well, please, somebody will tell whose address is this one. So only that computer whose MAC address this will respond back. Not all of those. So let's see how it works. So when a machine is sending a request, ARP, remember ARP is up to your network, not beyond your network, in the same area. So when this machine sends the broadcast, say, well, I want to talk to a computer who is 112, 113, or blah, 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 whatever. All these machines are listening because they are, this guy, this switch is broadcasting that or is asking that machine if it knows the address of that. If it doesn't know, it's sending a general broadcast and all of them are going to listen. But only one machine's address, MAC address is that. So that machine is going to respond back with MAC address. They are not like humans that, oh, I don't like you, so I don't want to give you my MAC address. So remember, broadcast means when your broadcast goes, it is, if it is general broadcast, which is all Fs. If it is unicast broadcast, that's different. But I'm talking about general broadcast here. So broadcast goes there and system is going to say, oh, well, this is my physical address, and now they can send the information through. Without knowing the MAC address of a computer on your link, communication is not going to work. I'm not talking about IP address. Please do not confuse this with the IP. Layer 2, MAC address, link to link. If I cannot get the MAC address on my next link, I cannot, again I'm saying, there is no way you can talk. Physical, like a bread, if you don't have a bread, you can't eat. Logically, you may say you have 10 bread, but it's not going to do anything for you. So layer 2, switch layer 2, physical frames, encapsulation. What they are sending is the media access control addresses. How they do it? By ARP. Next thing is, if you are a part of a hub, this is your broadcasting area. This is your broadcasting area. Oh, sorry, the collision area. More computers, more collisions. Okay, switch. How many collision areas in switch? Look at the ports, 1, 2, 3, 4. Because 4 ports are engaged, so there are 4 collision areas. 1, 2, 3, 4. So this is second thing. If I remove this one and I put all the computers in the same hub, only one collision area. So this is one collision area. These are 3 collision areas. So total 3 plus 1, 4. This is your 100% question for exam. Next question. They say, how many broadcast domain do we have? So broadcast means if you want to talk to a computer which is not on your network, all these are on the same broadcasting area. So collisions are depending upon your hub and the number of ports on the switches, but broadcast, they all belong to the same broadcast. So a lot of broadcasts, that means 500 people there yelling to each other, computers, nothing is going to work. So today what I'm going to do is, I'm not going to go into the broadcasting thing concept right now because my main goal was to show you when we are connecting devices, Ethernet devices, we use Ethernet cables. So what is the rule of the cables? If you are connecting the same layer devices or you are connecting the different layer devices. So if I want to connect layer 2 with layer 3, we use a straight through cable. But if you want to connect, let's say you don't have a switch, you don't have nothing at home, and you want to connect two computers, and without any the hub or switch. So then how do I connect? These are same layer devices. Computer, logic. So what I do is you go to the cable and now look at the broken cable. That is called copper crossover. Now what is this crossover? Students have a problem of differentiating between straight through and this. Let me make sure you understand. When I say straight through cable, I will type something here. You can read a book, but I don't know whether it's going to make sense or not. So straight dot T, that means straight through cable. So straight through cable means when you are sending it, you are sending on pin number 1 and 2, and the machine or the switch, that means the layer 2 device where you are connecting with, because either you are connecting normally with a switch or a hub. So they are also receiving on pin number 1 and 2. Okay, so you send from pin 1 and 2, they listen on 1 and 2. And when they respond you back, so let's go here. When they respond you back, now they are going to send you and you are going to receive, correct? To reply. So you are going to receive on port number 3, or on your pin number 3 and pin number 6. And what they are doing is, they are transmitting it now, because now it's their turn now. They are transmitting, you can see now 3 and 6. So basically same pin numbers. That's why it's a straight through. Computer transmits on 1 and 2, switch or hub receives on 1 and 2. When they reply, they send you on 3 and 6, and you get on your 3 and 6, because they are different devices. Remember, different devices, because your 1 and 2 and their 1 and 2 are not the same, because these are different devices. But if you have same device, look at this part here. So computer to computer, when you are transmitting areas now, because you want to send a message, you are sending from 1 and 2 because you are a computer. And there is another computer. Now that computer cannot receive at 1 and 2 because same layer device that is meant for the way we do those cabling, we do those twisting, so they cannot. So what do you do then? That we say we cross over 1 to 3 and 2 to 6. So they are going to go and receive on port number 3 and 6. Now when they are going to send you back, clearly you are at receiving end now. Okay, you are at your receiving end, and they do the crossover. So they will send you on 3 and 6, and you are going to receive on 1 and 2. So your 1 is going to go to 3 of the other, and your pin number 2 goes into 6 of the other pin. And similarly there, 1 and 2 goes into 3 of yours and 6 of that. So cross, that means that's what you are crossing over. Concept is simple, because you are same devices. If you transmit on 1 and 2, you cannot receive on 1 and 2. So, oh sorry, this is, they are going to go 1 and 2, I'm sorry, 1 and 2, and the other way is 2 and 6. This. Okay, so see the difference. So logically, what I am showing you here is straight through cable means transmitting, and the other device which is not on your layer it is listening, receiving on the same pins, 1 and 2. When that is sending, you are listening on the same pins, 3 and 6. Done. But if the devices are the same layer, logic, computers, routers, firewalls, then what do you do? So then you transmit, if you're a machine, you only transmit 1 and 2, or you are a router, you transmit 1 and 2. You are a firewall, you transmit on 1 and 2. But the other computer is also of your layer. It cannot receive on 1 and 2 because 1 and 2 is for sending. So then what they do, they say, okay, they are going to receive at 3 and 6. And now when they are going to send you back, you are going to go and receive at 3 and 6. This is called you crossover. Now these days, because of technology, we use a term called MDI. So this MDI or auto MDI, we use a term called auto MDI, media dependent interface. It may have X, may have no X. So if both devices have X, you use a crossover. If one is having X and the other doesn't have, they do write these things on the ports. One shows you X, the other device we are connecting the cable doesn't show you X, straight through cable. So these are 2-3 questions in your exam. Remember, there are 120 questions in your CCNA exam. And this is the first part which I'm just showing you fundamentals. Ethernet, you are connecting cabling. So only 2 types of topologies in your exam, Ethernet and wireless. More than 95% is your all Ethernet things here. So you make sure you know collision domain, CSMA CD, carrier sense multiple access. Oh, I got it now. I nailed it. Carrier sense multiple access. There are so many acronyms, so I can't recall all those. Carrier sense multiple access. And then the slash is collision detection or detect. Traditionally detect is enough. So what it means? This means before a computer is sending information, if they are on this kind of environment, okay, they are sensing the cable. If they are finding any movement there, any signal, they back up. They don't do anything. They wait for, there's a delay. And once they sense it, nobody is doing anything, then they put the information on the cable. But the question is, can we eliminate? No. We can only detect it, and then their algorithms, once they find out that you have done this one, like 3 strikes, remember, like in law also? Otherwise, the first time they say, okay, he's innocent, leave it. Second time, third time, they say, oh, he's a culprit guy. So similarly, in collision, if the same computer is having this kind of thing more than once, it is not backing off, or whatever the delay timing is, 2 to the power some seconds or milliseconds, they are going to say, well, discard this computer. So 3 things are in this lecture which you have to make sure you understand. If you understand that, that'll be great. Number 1, if you are connecting your computer with a hub port, okay, you are sharing. Because hub is a sharing thing, all dumb, physical. You listen from here, you talk, and then broadcast everywhere, amplifying, nothing else. So more computers, 6 computers, for example, in this hub, they can give you 6 computers, and all of them are going to go and collide in this area. Number 2, you replace a hub with a switch, so you now get 24, for example, if there are 24 ports which you are going to use, so 24 collision domains. So clearly, look at the simple average. If you have 50 computers, 24 this one, so 50 divided by 24, you can see now how many collision domains you are getting. Okay? So less number is always good here. More number is not good. Okay? This one. This is 1 collision domain. These are 3 collision domains, or 4. 1, 2, 3, 4. But the third thing I said, the next thing is the broadcast domain, and that will be how many broadcasting area are traditionally. This has nothing to do with the, oh sorry, this has nothing to do with make sure. Domain concept is not like a internet. Oh, this is Cisco's concept. So broadcasting domain means broadcasting area. No matter how many hubs, how many switches on computer, always one broadcasting area, one broadcasting area. Okay? So in this case, you can see now, you have 4 collision domains, 1, 2, 3, 4. And how many broadcasts? 1. Straight through cable, same pins. Listening, sending. Crossover, not the same because they are different devices. Crossover for different layer devices. Straight through different layer devices. Crossover, same. These days, I said MDI, media thing, distinct system will pick up all of that medium by itself. Auto basically is all auto. So it's very smart now, auto MDI. So media detection interface system will pick up. But to learn for exam, make sure I will discourage you not to use this cable because it will connect by itself and you won't know what's happening. For this course, keep learning about crossover cable and the straight through cable. And then tomorrow we will introduce the next cable, which we call DT and DC, but that is not for today. Okay? So whatever I have talked today it is all relating to my first and second lecture, OSI layer models, TCP/IP and OSI. Remember, they are layers. And what is the right now the 3 important layers which we are experiencing today is layer 1, physical, because everything is moving in bits to the other computers. The next thing is a layer 2, data link layer, which is all depending upon your topology, Ethernet. So if it is Ethernet, MAC addresses, media access control. And the third layer is your network layer, which is the IP. That's why I gave IP addresses. So ICMP, I showed you. ARP, I showed you. IP, well, this is IP address. So layer 3, logical. Layer 2 and 1 are physical, but because of distinction, we say, distinction thing, we say, oh, layer 2 is decides the topology, 82.2 or 82.3 or 82.11, whether you are working on Ethernet or you're working wireless. And layer 3 is going to go and use the connector devices accordingly, whether it is your Ethernet hub or switch, or you have a wireless modem or wireless router or wireless switch, those are access points, or repeater or hub. So we talked about 3 things and I showed you practically how they look like. I didn't talk about transport layer 4 yet. No, we didn't talk about that. So tomorrow what I'm going to do is, tomorrow I'm going to add a router. And then I'm going to show you that how do we go and make more than one broadcast. So to reduce the broadcast, you add a router. But you can only add a router if you want to go out to some other network. Like you always open your main door if you want to go out. If you are not going out of your home and you are opening the doors within your home, bedroom, dining room, kitchen, bathroom, or washroom, it's all the same, within the same network. No going out. So you are in the same broadcasting area because you know each other. But the moment you want to go see the strangers, because you open your main door, you want to go out, some other network, I don't know what, but some other network, then you are getting into a different broadcasting area. That is not your collision area. Okay, so we are going to go and talk about that tomorrow. Hopefully you enjoy my lecture, and I expect your comments, because to improve, remember, we always keep improving, and learning is a two-way process. We always learn from each other. Two-way traffic. It's not one way. So we can only improve when we give comments and then we try to improve it. Suggestion and all that, and keep in touch. So we keep on learning. Okay. So what we are going to do is tomorrow we are going to go into a little extending same concept. And then until then, take care.